Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section, we're going to build upon what we did in the last section in arc length, and we're going to use that information to cover the topic of what is known as the area of a surface of revolution. It's a big, long title. It's a simple concept. All it means is, let's say you have, and I'm going to draw it here in a second, but just to use our heads here for just a second. Let's say you had a function, right, that's floating right out in front of you and me. Some function that's a squiggly line derivative, and then plug the whole thing in here, and I'll be able to arrive at the answer. So let's do that right now. Let's find the derivative, okay? Okay, so what we're going to do first is we're going to take the derivative, but before we do that, we're going to take the derivative of this. But before we do that, I'm going to rewrite it as 4 minus x squared, all raised to the power of 1/2. And the reason I'm doing that is because I don't like radicals running around when I'm actually taking derivatives. I like to write them as exponents because you're going to end up using the exponent rule to take the derivative. So that would mean that f prime of x, the derivative, just using your exponent rule of derivatives, times, I'm just going to evaluate x at the top and the bottom, so it's going to be 3/2 minus a negative 1/2, because it's minus and I have a negative 1/2 here, so I'm going to have 4 pi, and on the inside here, I'm going to have 3/2 plus 1/2, okay? And so then finally I'm going to have 4 pi times, I already have a common denominator, so it's going to be 4 over 2, so it's going to be 4 pi times 2. The answer is going to be 8 pi. Okay, 8 pi, and that's the answer. Okay, so review with the radicals here, with the arc length and with the surface area here. We've always tried to beat this thing into shape and take a nice square root and cancel some stuff and move about our business. But that isn't really going to happen here because there's nothing to do. It's already simplified. So what do? Now think back. If you can't find a nice way to factor something or get rid of it with taking the square root, which we can't here, then just go back to your basis. Is there a simple substitution that we can do that will solve this integral for us? Now the first thing you notice is you have an x to the 4th here and an x third. So it's going to be 2 pi over 3 times the integral of 0 to square root of 2. Okay? And I'm going to have x cubed here. I'm still going to leave that along for the ride, but what I'm going to have in the middle here is I'm going to have square root of u, this is square root, and what I've defined u is going to be right down there, and then I've got dx, and I'm going to plug in what I know for that, which is 1/4x to the 3rd power du. Okay? Now what's nice about this, obviously the reason we did it is the cancellation that you get here. Okay, so it gives you 125. Well, you have 5 times 25, and you have 25 can be 5 times 5, and I'm taking the square root. So here's a pair right here. So what I have here is pi over 9 times 125 square root of that is going to equal 5 times the square root of 5, because here's a pair, 5 times the square root of 5. Don't forget I have minus 1 right there. And that is the answer. Pi over 9 times 5 times the square root of 5